Hi, this is author and artist Alexis Marie Chute. Thank you for coming to my channel on YouTube. Please subscribe. Okay, so July is a very important time of milestones in the space community. So July 16th was the day that the Apollo 11 mission launched, and that is the mission that put man on the moon, which was super cool. So I've got moon on the brain because my novel, Below the Moon, is coming out this October. If you want an advanced reader copy, email me. My email address will be below here. So Below the Moon, the 8th Island trilogy, it doesn't take place in our world. It is a magical fantasy adventure. At the same time, I've had to do so much research. That's something that's really cool about being an author. I've learned so many crazy things. So some of the research that I've done and that I'm continuously doing is about space and is about Greek mythology and is about the way that we believe and we discover our place in the greater universe. So this is why I'm really excited to be sharing about the Apollo 11 launch, and also I'll be posting another video about July 20th, which is the day 50 years ago that they actually landed on the moon. So this is Erin Chute and her family at dinner on the 50th anniversary of the moon launch. And Erin is going to explain how the Crayon rocket ship lands on the Corona.
Yeah, the Corona moon.
Corona moon.
It's better than moon cheese. All right, so here we go. Here's the rocket ship taking off. And the rocket ship was called the Saturn V, and it was like the strongest rocket ever made. So the Saturn V rocket launches off, and as it goes up, a piece of it breaks off, and that falls back to Earth. Because this is like where all the gas, the fuel goes, so it falls down. And it goes up, and it takes a few days to get to the moon. And it goes around the moon, and around the moon, and around the moon. And what happens is actually the rocket ship had a little lander, they called it, a lander inside of it. And what the lander did is it, and this thing kept going around the moon, so this had the third guy in it, and this had Buzz Aldrin and Neil Armstrong in it. So it lands on the moon, and this guy keeps going around, and these guys do their thing, and then they get back into it, and they go, and they link back up with this, and then they go, and then they head back to Earth.
And then they will crash.
So that's why the third guy didn't go to the moon. He had to stay running this thing.
Oh, they couldn't leave that alone. We were wondering
they couldn't leave
why.
it alone, so they had to leave this guy.
One guy had to stay back.
So 2 guys went down, and the 1 guy stayed up top, going around.
And look at that Corona moon.
Yummy, I guess.
Tilt it a little, make it a bit easier for you.
Yeah, right on there.
All right. Now stand behind that line over there. So, hey, you guys watch. So, we're going to launch our rockets in 3, 2,
Oh, here goes, guys.
1. Whoa! 2, 1.
Luke, are you on Mars?
What's up here? Look up. Is there anything up there?
Can you tell me what you
So
see?
if you pull the trigger, you can pick stuff up.
Are you gonna stand or are you gonna sit?
I'll stand. Oh, it's like a lightsaber.
If you pull with your trigger, you can pick up a couple different objects.
I don't know if hand gestures help her, you know.
Probably not quite.
How was it, Heather? Alexis, what do you see?
I am lifting some magic device. Oh, and there's a wheel. Can I put it back on? Let's see.
Oh, yeah. Rover also.
Okay, I fixed a wheel.
Yeah, you can go for it.
I just was able to move a wheel.
Oh. See, with the power of the Force, I'm lifting things. quite exciting.
Did you know we're going back to the moon in 2024?
I did not know we were going back to the moon in 2024. Tell me more.
So it's called Artemis. I don't know if you know much about Artemis or not. Artemis is the twin sister of Apollo, so that's why we chose that name, right? Because Apollo was our old mission, right? 4-person crew.
Any women this time?
So they have said yes, but here's how, and I expected there to be women on board.
Okay.
But NASA historically has chosen the astronaut that is up in the right rotation and has the right skills, right? So if it happens to be all women have the skills needed for this mission, it could be an all-women crew.
Yeah.
You know, I'm kind of proud of that. They don't.
It's based on skill, not on gender.
Right.
Yes.
But they have said on Artemis that a woman will be there. So I assume that means they've already analyzed their skills, right?
Well, I picked up an issue of National Geographic and it had an article about women going to the moon and why it has not happened yet. I haven't read the article yet.
I haven't read it either because I can't. The only now in Apollo days, there were no women in this astronaut program, right?
Yeah.
So the chances of a woman going into Apollo was non-existent, right? Which wasn't fair, but it's what it was. Even though the mission is named for a woman, Artemis, you know, it's the sister of Apollo.
Artemis, the sister of Apollo. That's super cool.
So, and she's actually goddess of several things, including the moon.
The goddess of the moon.
Several things. One of them is the moon.
Well, that's perfect.
Yeah.
See, it's meant to be.
Yeah, we're going to the South Pole where you're standing. One of the reasons why is we know there's a lot of water on the South Pole.
The South Pole of the moon.
So the craters on the South Pole and the North are permanently shadowed. Sunlight doesn't shine on them.
Neat. Okay.
So because of that, the water stays frozen in them instead of evolving away, right, from the heated sun.
So is it going to be a much colder mission?
Yeah, so it would be, I'm trying to remember the exact temperatures. So in the sun, the moon, I think, is 268 degrees Fahrenheit, I think. And I think it's like negative 268 in the shadow, right?
Okay, so very, very, very cold.
Yeah, so the only thing is if you're on the area that's just like gets a little bit of sun, right? Because as you get further out from the pole, you get like a sunset-y kind of amount of sun.
Okay.
That would be actually a nice temperature because it wouldn't be all that hot, it wouldn't be all that cold. It wouldn't be direct sun, but it wouldn't be like no sun at all either, right?
But down here in the South Pole, so these are all frozen.
Yeah, so I know the ones in the center here are never get sunlight.
Never sunlight.
Never get sunlight.
Okay.
So, and same thing on the North Pole. But we're going to the South Pole. So those are have frozen water in. Now, if you get way out here on the South Pole, I don't know each individual crater well enough to tell you.
Okay.
But I'm assuming some of these do get sunlight because they're not that close to the center of the Earth.
So when you say South Pole, maybe this is a dumb question. Are we like literally looking at the bottom of the moon?
Yeah, I mean, well, no and yes.
Okay.
So in space, how do you determine what's up and down?
I don't know. That's a good question.
We have our perspective from being Earthlings, right? When we look at the moon, we think that part's the top because we see it at the top from our point of view.
Yes.
Up here, right?
Yeah.
So, but also is the northern hemisphere of the Earth the top of Earth? I mean, there is no up and down really in space, so that
is a good point. That is a very good point.
So it depends on how you look at it, I guess.
Yes, everything's about perspective, right? And who are you?
I'm Dr. Baron Summers. I'm a NASA Solar System Ambassador.
Awesome. And you work here in Phoenix?
I live here in Phoenix. I sometimes do remote work. Now, I'm not paid by NASA. I have a position with NASA, but this is volunteer work.
Oh,
this
awesome.
is professional service. Scientists are supposed to do things that contribute back to science in professional service for free.
Cool.
And so this is one of the things I do is...
You're giving back and having fun at the same time, right?
Right.
Yeah, awesome. Thank you. Okay. Baron, Dr. Baron.
So the dominant theory right now is that a small planet roughly the size of Mars hit the Earth. When the two collided, there was massive debris ejected out, and that coalesced into the moon. And actually, we know in part because Apollo missions brought back rocks from the moon, and they're the same composition as Earth. So the only way that really happens is if it came from Earth.
So I know there's no dumb questions, but how, okay, so if another planet collided with Earth and formed the moon, and we all see the moon in the sky, it's this beautiful sphere, how did it get round? Like time?
Well, that's gravity, right?
Gravity.
I mean, so if you have enough gravity, it's going to compress from all angles, right, and create a sphere.
Okay.
So all your planets are round. You don't see a triangle planet, right?
Yeah.
Or square or anything else.
Because
Right?
gravity sucks everything to the center.
Right. It's equal around, so they're all round.
Okay.
Stars are round. The sun is round.
Everything's round.
Everything's round. Once it gets to a certain level of gravity,
Yeah.
Mars has some moons that are really, really small. They're not round because they don't have enough gravity to make that happen.
Okay.
Our moon is huge for a moon.
So did we, as planet Earth, give the moon our gravity?
No, anything that has mass has gravity. So I have a gravity because I have mass, right? So it's just so weak you can't tell, right? So the moon has 1/6 the gravity of Earth because it's a lot less mass than the Earth.
Okay.
So yeah, anything that has mass has gravity. It's just you have to have enough gravity to make it turn into a round shape.
So how come different planets have different amounts of gravity? Like the moon, when you go on it, you jump, and
Yeah.
it's like you're airborne for a little bit, right?
So it has a lot less mass. So
Okay.
it has 1/6 the gravity of Earth because it has so little
Because
mass.
it's 1/6 the size of Earth?
It's not 1/6 the size. Things can be different sizes and not be.
It's not all proportionate.
Right, because it's what it's made of and how packed it is together. And so if you have something like a gas planet, it may not be as dense as a rocky planet, right?
Gas planet.
Although gas planets tend to be very big, so they might actually have more mass than Earth, depending on.
Well, that's interesting. I'm an author, and my book is called Below the Moon, and my first one's Above the Star, and the next one's Inside the Sun. But I write about a gas planet, but it's more fictitious, fantasy, adventure, than this very concrete, amazing moon facts. Okay, so you saw me talking with the NASA volunteer guy about women going into space. And this is something that, obviously being a woman, I care a lot about. So I had mentioned this article that I read in National Geographic. Well, I didn't read it at the time that I talked to that guy. That's my 3-year-old coughing. Anyway, so National Geographic, let's send only women to space. So I've got some really interesting facts about women in space. In the about 58 years of us sending humans into space, only about 11% of those people have been women. There are many pros about sending women into space. Number one, we're typically smaller than men, aka we need less food, less space, less resources to keep us sustainable and alive and thriving in our space mission. Smaller people also produce less waste, like carbon dioxide and the things that come out of us, which means less strain on our space vehicles. And there's also the fun, futuristic reason why it would be great to send women to space, and perhaps an all-woman flight crew, is if we plan to reach a new planet and repopulate it with, of course, our beautiful race. So women, if you send an all-women crew, you have greater genetic diversity. You don't need men to do the equation. You just send women with the means to self-impregnate, and and then you have a great amount of genetic diversity. Women are lighter. Women can go and fill this new world and make lots of babies and happily ever after. So the different genders have different pros and cons and strengths and weaknesses when it comes to going to space. So Men experience less motion sickness than the women, but they also experience huge issues with hearing loss and the loss of vision, blurry eyes and stuff. And so it's really, really challenging on men's bodies. At the same time, women have more urinary tract infections. I can't believe I'm saying this in the video. But we have less eye problems, and women are also a little bit more social beings. Although when I read that report, I was kind of like, has anybody ever watched The Bachelor or The Bachelorette? Women are like, they fight like cats and dogs. So I don't know. We'll see. Maybe we are more like loving and nurturing and, oh, we're on this long space flight together. Let's be BFFs. We'll see. It's also very interesting to note that NASA defines sex as our male or female genetic makeup, whereas NASA defines gender as our expression of male or female in social settings, our social interactions. So when NASA is looking to fill their spaceship with lovely astronauts, they're not looking at gender, which can have many different implications. They're looking at sex and which ways that will affect their mission.
Mr. Jeff.
Mr. Jeff,
How are you?
hello. All right, let's look at this. Tell me what we're looking at.
So we're looking at lunar samples that were picked up during Apollo 17.
Apollo 17.
And so we have some rock samples here and some soil samples. And you can pick it up, put it closer. Yeah, put it in your hand. You can say you're holding the moon.
I'm holding the moon. Now, isn't that cool?
So these were taken from the last time we had humans on the moon.
Okay, so tell me about these different, so these are rocks, right?
Oh, so
Rocks?
right behind us we have where they were picked up. That's Apollo 17. Right.
Right where my friend is. Hi, friend. Okay, so
those samples came from where he's standing.
where he's standing, right there. That's where those samples, Apollo 17, 1972.
So different rock samples on there, and what we have here are earth rocks. And we have basalt, which is right here. And you can compare that with the moon version of basalt.
Where is that here? There it is.
Yep. And then we have anorthosite, which looks a little bit different than the moon version right here.
So were all these tiny little rocks, like do so many museums across the states have these?
Yeah, so this came from larger samples because our astronauts didn't go there and pick up, with tweezers, tiny different samples. So they brought back larger samples. In total, we brought back about 880 pounds, I believe. Yeah, it was less than 900 pounds. And so we took a larger chunk, and for educational purposes, they divided them up and put them in these nice acrylic discs here so that educators can borrow them from time to time.
Well, I'm putting my pen here as a scientific demonstration to show the scale. So these tiny little things we've got.
They're very tiny, but very rare. I could probably say this is something that you don't see every day. We don't have a lot of these. We also have a soil simulant. This is a lunar soil simulant, meaning it's not real, but it has the same color, texture, and consistency there. And so they created that by picking up samples of volcanic ash from Flagstaff, Arizona.
From Flagstaff, Arizona. Cool.
Yeah.
Because we are in Arizona.
Yeah, we're in Arizona.
That's awesome. And you get to carry this around in this cool little case.
Yeah, it's a nice retro case. It did not come with handcuffs, which everybody jokes that it should, but it's kind of nice to bring around.
Yeah.
And so I have this on loan for a few days and just showing everybody.
To celebrate for the 50th anniversary.
Definitely.
Awesome. Well, thank you.
Thank you.
Thank you very much. Bye.
Bye.
Let's see you fire that rocket, Luca. Boom. Oh, you hit some people. Sorry.
You got me!
Sorry.
Oh, you're fine.
No, it's
ready?
okay.
You ready? Oh, I know.
Oh, that was a fail. That was a fail.
Fail on.
I didn't see it. This is not a rocket. This is an airplane. So it is 8:14 on the day that the moon launch took place. And that is the moon. So there's a dot right there that's the space station. Something right there. Space station moving across the night sky. So we saw the space station, but it's going to come again at 9:47, you said?
Yeah. And then tomorrow again at 4:18.
And so how long does it take to travel around the moon? Is that what it's traveling around?
No, it's traveling around Earth.
Traveling around Earth.
So it just started here at 8:11, and the next one's at 9:47. So if we take the difference, about an hour and a half.
An hour and a half to go around the whole Earth.
Yep, 17,500 miles per hour. Is that crazy?
You're a wealth of information. Thank you. Okay, so tell me how to do this, Hannah. This is a star wheel.
Facing, if it's midnight and like if it's 1 a.m. and it's June 15th, and if you're facing south, you'll see all these constellations like this.
Oh, that's so cool. Getting close to the line here. And that's the moon right there. It's huge. And yellow, but you can't really see it well.
Pretty cool, Hannah?
See all the craters on there?
Oh, that was
Just to let you guys know.
The moon doesn't actually have a very thick atmosphere like our planet does.
I took a video.
Here, it looks like there's a little condensation on there.
Hey.
And the atmosphere was a little
Ooh, it's so close.
Which angle?
Yeah, I'll come join you.
Oh, that's so cool.
Yay.
What a cool video.
Oh, that's so cool. Thank you.
No problem.
Yeah, this is the big telescope that's looking at Jupiter. Yay, these are the folks in this yummy, delicious snack shack on the road. Woo! Thank you so much for joining me and learning more about the day that Apollo 11 took off and went to the moon. So my next video will be about the day that we actually land on the moon. So that's gonna be pretty epic. So join me. Please subscribe to my YouTube channel, follow me on Instagram, and connect. I'd love to hear from you. Have a blissful, amazing day.